Hello, this is Dr. Flight, and I wanted to do a short demonstration on something called the two-stage or two-step cluster analysis. So this is an alternative to the k-means or hierarchical cluster analysis. And what we'll do is use the HBAT data set that's available to us. I have it pulled up here, and you'll see that there are a number of different variables. In fact, we can switch to variable view, take a look at what we have available to us, and actually while we're right here, I'm going to clear this information out from an earlier data analysis that was run. And what we're going to do is we're going to cluster customers. Now, this is the HBAT database with 200 respondents. So if you want to do this yourself, you can go ahead and play around with it. But what we're going to do in this particular one is classify customers based on elements that are perceived to be negative and the negative perceptions that they may have of the HBAT company. These would be things where we want to maybe find customers that are at risk of leaving, or customers that are at risk of providing negative feedback to other customers, negative word of mouth, and things of that nature. So we're going to do a two-step cluster approach, this method kind of combines the a k-means method and a hierarchical method. The other thing is this method is the one method that allows for both categorical and continuous variables to be run if desired. So that's an advantage of this particular method that you'd have over other methods. So basically, SPSS allows us to do this. We're going to go to Analyze, Classify, and then two-step. So we're not doing k-means or hierarchical, but we'll do a two-step cluster analysis. I've gone ahead and put some variables in this continuous variable area, but remember we could also have categorical variables in there as well. I tell you what, I'm going to go ahead and put a categorical variable in there, put industry type. So this is, I've been playing around with this, so this is something fairly new to me. So I'm going to put that in there though, because I can. And then I have these other elements here. So complaint resolution, technical support, warranty and claims, order and billing, and then delivery speed. So these are all things that I feel like might be important to this particular analysis that we have here. And these are the variables that will actually be used to group and regroup the customers into specific clusters. Again, with cluster analysis, depending on what methods you use and the procedures you call for, you may arrive at different solutions. So there are some options here to consider right on this first page. For one thing to consider here is the number of clusters down here. So we can let SPSS find the best solution, or we can specify the number of clusters we feel like we would like it to find for us. So we could force the number of clusters here that we're asking for, or again, we could have SPSS calculate those for us. Now, it has 15 variables or 15 clusters, but we could, that would be way too many probably for us to be able to analyze. So you could limit it or reduce it if you wanted to. That would be fine as well. A couple other points here. Well, with this in mind, you can choose the Bayesian information criteria, the BIC or the AIC, the Akaki's information criteria. So the BIC and the AIC are the fit measures or the fit calculations to determine what the best solution would be. So in other words, would the best solution be two clusters, 3 clusters, 5 clusters, and so on. So we'll have a table that produces one of these two criterion measures between 0 and 1 for as many clusters as is offered in the number of cluster area over here. Now, when we specify our own, we don't have that because we're telling it to do 3. But if it's deciding on its own how many to produce or what the best solution is, then it's going to compare like a 1 cluster solution to a 2 cluster solution to a 3 cluster solution based on the best fit. And so one of the suggestions is actually to run your model a couple times with either one of these checked to see what the final solution is, and then interpret it from there. That's an option there. Now, the other thing that you'll notice that box is only open when we determine automatically the number of clusters. The other thing is if we took out the categorical variable, then you have a choice of either log likelihood or Euclidean distance as your choice in distances. So again, with continuous variables, you have a choice of distance measure. And again, you may want to run your model a couple times, one with log, one with Euclidean, and just see what the difference in centroids are, and distance to centroids, average distance to centroids by cluster. If you change the clustering criteria, then you may get different cluster solutions like 1 or 2 or 3 or 4. Okay, so for right now, I'm going to put that industry type back in there again just to kind of see what it does. And that explains this first set of options on this page here. Other options that we could have, if we actually clicked the options box, we're not going to really mess with this too much right now. The variables will be standardized through the process of doing this. Now, these variables are all on the same scale. So the continuous variables anyways. So they we could actually move them over, probably assumed to be standardized. But remember, one of the issues here will be outliers and the standardization or the scale of the data. You want to make sure the scale is consistent. But we're not going to mess with that here. Output, I want to mention just a quick thing here with output. It may be that you want to compare clusters on certain outcome variables. So in other words, what we would normally do is we would take our cluster membership and then we would do some ANOVAs or t-tests just to see how the groups differed by certain outcome variables. Well, in two-step cluster analysis, we're given the opportunity here to include what they call evaluation fields. So in this case, I have likelihood to recommend. I could do satisfaction or any of these purchase likelihood, likelihood to purchase level. So those types of things are all sort of these outcome variables. And I just happen to choose likelihood to recommend. This is a variable, though, that will not be used to form the cluster. Rather, it'll be a variable that we can look at and examine to see how it is different between groups. Okay, so I'll just continue that, and we're going to run the model and do this and see what happens. Okay, so this is the two-step cluster. Auto clustering here is what we chose, if you recall. You'll remember that we chose the Bayesian information criteria, the BIC, as opposed to the AIC. And as you add clusters, this diminishes which is what you want. The other thing that we'll look for are big changes or big drops here, and then a leveling off. So again, the software automatically calculates, based on the BIC in this case, the best fit relative to change in fit. So it looks like it has chosen 2 clusters, and it has looks like it's evenly split between 100 in each cluster. So there's something interesting going on here, because it took 100 and put it in 1, and 100 and put it in 2. Now we have our cluster profiles. So this would be the average score for each cluster by the variables that we chose. So we have complaint resolution, technical support, warranty and claims, ordering, and delivery speed. So those can be examined, and then this is where it is, industry type. So there are 2. So we remember we had a we had that one categorical variable, and it was industry type, and there are only magazine industries or newsprint industries. So what is happening here is that one variable is it is controlling the entire mechanism here. So this is actually an interesting finding, that industry type is actually controlling the overall results, and it is masking the importance of any of these other variables. So we really don't know how important these other variables are, because it looks like industry type, so 100 100 of the respondents were in magazine and 100 were in newsprint. So that's what created the clusters. All right, and now this box here, we're actually going to double click on this box. And as you double click on this model summary, another viewer comes up, which will be interesting for you, because this will help us analyze the data. So if we looked at this cluster size pie chart, we see that half the clusters and half the subjects are in one cluster, half are in the other. If we click down below here on Predictor Importance, yeah, see, this is what's happening. This is that metric, that non-metric variable, the categorical variable, industry type, and it is the one variable that is overshadowing all the rest. So basically what happened here is the data was all just simply clustered based on that one variable. And so the other variables that we asked for were non-impactful at all in terms of importance. And this last one, likely to recommend, that would not have been used at all. That's just there because it's the measure that we're using to indicate whether the groups are different or not on likelihood to recommend. So it's not used in the analysis. These others are, and they have no role to play here in assigning cluster groups. So that's a problem, and that's something that we obviously want to address. So we're going to actually take out industry type because this is not particularly telling. It would be interesting probably if we forced it to maybe give us 3 or 4 or 5 different clusters by themselves. But otherwise, this is not really something that's going to help us here. And in fact, if we click down below here off of model summary and clicked onto clusters, we get even more information. In fact, what we can do is we can sort these clusters by the most important variable. So industry type here is the most important variable by a large margin from all the others. And so yeah, so that's what we're finding out there. So we're going to close this, and we're going to rerun the analysis. Only this time we're going to remove industry type. And that will allow us to see what the real effect of these other variables are without the presence of industry type there. So it was actually good to do this because it helps us understand or helps us realize that, number one, we can use categorical variables, but also that we can look and see the relative importance of each variable based on the output that's were provided. Okay, so now this, after rerunning it, we have a two-step cluster again. We have our auto clustering based on the fit of the BIC statistic here, which again diminishes when you have each new cluster. However, we want to look for big drops and then subsequent small drops. And that would be the breaking off point that you'd look for. Here again we have a two cluster solution. There's 95 in one, 105 in the other. We have the centroids that we had like before, so these would be where individuals in each cluster are on average based on each of the variables. And then we have our summary, our model summary. So again, here with this technique, we can double click on model summary, and we are provided with an outcome, kind of like a dialog box here where we can print. We can use these, we can copy these, we can use these in reports. We have our different cluster sizes, ratio of sizes. Let's go ahead and just click on Predictor Importance. Here we go. So when we do predictor importance, we have complaint resolution and delivery speed being very important overall, followed by order billing, likelihood to recommend. So this one here is actually not used in the analysis. So remember, this is, although if we put it in, it would be fairly important in terms of the analysis, but this was an outcome variable, so it actually was not used in our analysis. Warranty and claims was, and technical support was. Neither of those were nearly as important, though, in actually designating group membership as order and billing, delivery speed, and complaint resolution. Okay, so that's a beginning analysis. If we move over to the model summary side and we click down here, we click on clusters, then we get a report here that provides a reflection of, again, which variables are most important to the overall analysis. We can click on this little button here, and again, it'll tell us which variables were important for each cluster. So cluster 2 ended up being the largest, so it's listed here first. And we have the box plots for these, for these individuals there, box plots for these here, but also importantly, we have a description of where the respondents in each cluster fell in each variable. So here, cluster 2 on delivery speed, they were to the far right. So cluster 2 represents people who were happy with delivery speed. This cluster 1, represents people who were unhappy generally with delivery speed, also unhappy with complaint resolution, while cluster 2 are the ones who were happy with complaint resolution. So it seems like cluster 2 are the individuals who are unhappy, and cluster 1 are the people who are generally happy. And those are the two clusters that emerge here. One last thing I want to show you, so you can click lots of these buttons on the side here and kind of get different graphical demonstrations of the data. If you click display, and if we add under display evaluation fields, remember we had likelihood to recommend as an evaluation variable. It's not a clustering variable, but a variable we wanted to see its impact across the different clusters. So I'm going to click OK, and we have likelihood to recommend here. Now as an evaluation field, again, not as part of the calculations, but likelihood to recommend for group 2. Again, this is going to be, if we just look graphically here, we see these are the individuals skewed to the right. Likelihood to recommend for cluster 1 would be far to the left. So we've got 2 clusters. A couple other things just as we wrap this up. In the analysis process, remember we used, in this case, a Bayesian criterion. What if we use the AIC criterion? So we're going to use AIC now instead of BIC. We'll click OK. We have 2 clusters, and we can continue to look and identify any differences. Now, one of the interesting things here is the AIC tends to it tends to understate the number of criterion. Okay, so it may be, so it's definitely beneficial to do both the AIC tends to overstate the number of criteria or clusters. The BIC tends to understate the number of criteria. So in other words, like we might get 2 or 3 clusters if we do AIC. BIC may only give us one cluster or 2. It may understate. So if we do both AIC and BIC and compare the 2, then it helps us better evaluate the overall results. Okay, so be sure to run a couple different methods or models here under the 2-step cluster. Feel free to, and again, you can try both Euclidean and log likelihood. So we could actually run 4 different models here, a number of different models doing different clustering criteria as well as distance measures. The other thing that we can do is we can specify, like I've got 2 cluster results. What if I really want to do, and I want to have, maybe I think there's a high, medium, and low as opposed to just a high and a low in terms of customer evaluation. So maybe I want to fix it to 3. So I use 3, and I have, again, distance measure options that I could choose. I'm going to click OK. And now this time I don't have the BIC or AIC fit criterion because I specified when the process should stop. And I should say the 2-step process basically does like a k-means assignment initially, and then the second stage is that it does a hierarchical ordering of the variables of the clustering groups. So it actually does 2 steps or 2 stages, which combines a k-means approach and a hierarchical approach. And so basically what I'm doing is I'm turning off the hierarchical approach when I specify the number of clusters that I want. So that's why it's called 2-stage or 2-step clustering to begin with. And so now I don't have the BIC or AIC fit because I've told it that I want a specific number, and so that's what it's provided here. And again, we have our centroid table. Double click here, and this is interesting. Okay, so we had 3 clusters as I specified that. However, they're not very evenly distributed in size. So the smallest cluster only has 4.5% of the population, then 14, and then 81. So when I force it using Euclidean distance, I get one overpowering cluster. I'm actually going to rerun it again just for fun with log likelihood distance as a measure, and again we have 3. Now look at that. See, that's a whole different model, isn't it? We have 3 clusters using log likelihood as a distance measure that gives us a much more distributed view. Let's look at our predictor importance. Okay, so these are all 5 of our variables are fairly important. In terms of, between very important here on a 0 to 1 scale, our lowest of our predictors is 0.45 for technical support. So these are all important in identifying which group would be where, which respondent would be in which group rather. And then finally we have our analysis by variable. We can click, this is an interesting thing to do, click here, and this identifies which variables are most important by each cluster. So we have complaint resolution most important for cluster 1, delivery speed most important for cluster 2, and then warranty and claims is most important for cluster 3. So this helps us understand the distribution or the spread of actual variables by cluster. One last item here, we're going to evaluate likelihood to recommend by cluster. And so here we have cluster 1 is a 6.47. Cluster 2 is much better, 7.58. And then we have a 7. So if we were to look at this in terms of likelihood to recommend, the number 1 group is skewed heavily to the unlikely to recommend. The cluster 2 is skewed heavily to the very likely to recommend. And then cluster 3 is sort of neither. Like they're in the middle. They're the middle group here. And so that's what's there. And now we would then create customer profiles, or the cluster profiles rather, to be able to describe each of the clusters based on the data that we have by variable and by outcome. Okay, so this has been a fairly straightforward discussion of a 2-stage or 2-step cluster analysis process in SPSS. So be sure to practice this and test this out and try this yourself. If you have any questions, feel free to ask. Thanks.